Hi guys, it's Miss Buck. Today's lesson is going to be on cladograms. We want you to know what they are and how to use them, and even a little bit about how to design one. You will need this when you take biology at Dobbins Bennett. And so because of that, the science teachers decided that we would actually each make a video and kind of walk you through this lesson. And so I'll make a lot of mistakes. So just bear with me as I go through, and hopefully we'll get there. All right. When we started this unit on the theory of evolution, one of the questions we asked you was, why do people always talk about this tree of life thing, and why is that an analogy for evolution? And so here's a tree of life. And you notice that on this tree, we've got a couple of different things represented. And then right here at this point, it talks about all life. And so I want to show you, this is a website that actually has an interactive tree of life. And I want to show it to you to kind of help us answer that particular question. So I'm going to go over here. When you go to this website, and I'll put a link in it for the lesson for you, it loads slowly. So just so you know, if you want to mess around with it, it does load slowly. But this is an interactive tree of life. And the whole point of this tree of life is to show you how all the living things on the earth are related to each other from a standpoint of evolution. And they don't have every single species on here, but they've got over 2 million. So that's pretty dang good. You click right here and you can start exploring it. Over here, this kind of gives me wackadoodle. I think this is a tutorial, but I can't watch it. It gets me a little seasick. If you get overwhelmed when you click that, you can also go down here, and they just have some different things that I guess some people like to get on there and mess around and explore. You know, if you like your squid and octopi, you might click there. What else do they have? Yeah, maybe like owls are your thing. So you can click right there and it will take you directly to the tree of life part that has the owls. But I wanted to start the lesson with this because I just wanted to show you where you are on the tree of life. And the way they have this designed, every leaf represents a species. So we are the human species, and we have our own leaf. On this website also, if the color of the leaf kind of shows you whether or not that particular species is on the endangered species list. So you notice we're good. I'll back out a little bit. You can see my friend over here, the golden lion tamarin. Look at that cute baby. Is not as good. But I want you to see, I'm going to start backing away, and you see if you can follow where the leaf is here, and start thinking about how connected and related everything is. So as I back out, you'll notice immediately that on this little segment of the tree, there's our leaf. And we've got chimpanzees, and I never know if this is pronounced bonobo or bonobo. And every year I think I'm going to look it up and I forget. And we can back out. I'll move it over here. Here's our African apes and our great apes, our orangutans, and our cool things here. Oh, they're so cute. So that kind of makes sense. All right. This is sort of one of our little branch right here. There's a branch. Because remember that the closer together these species are, that indicates that they have more characteristics in common, that we share more DNA, for example, that is similar, and we have more traits in common. So I'm going to keep zooming out. Now you see if you can keep track of our leaf here. All right, so I'll keep zooming out, and still got our leaf? Still got it there? Okay. So this is okay. I noticed that this kind of makes sense. This does not say, remember, the theory of evolution does not say that monkeys turned into people. That is not correct. What it does say is that at some point, millions and millions and millions of years ago, there was some common ancestor. And over millions of years and long periods of time, under the pressures of natural selection, that organism has changed and evolved into these different organisms that we see today, including us. But I'm going to keep backing up. Let's back up a little bit more. Oh, look, you still got our leaf. Did you lose the leaf? Yeah, did you lose a leaf? I think it's somewhere in here. So I'm going to go, oh, there's a tree shrew. All right, so now this is getting interesting. Squirrels, porcupines, chinchillas, rabbits. Let's keep going. Oh, let's keep zooming out. Oh, elephants, little marsupials. But we still all are mammals. This makes sense to me. By the way, you're somewhere in there. We are all mammals. Let's keep going back. But how are mammals related to other things? So look what happens if we keep going back. Keep going back. Did you lose the leaf? Keep going back. Oh, fish. Keep going back. I'll just keep going. I'll just keep backing out here. I'll just keep backing out here. Just keep. I lost the leaf. If you had it, if you still got the leaf, you're in better shape than me. And you notice that even though we are one little leaf out of all of these millions of leaves, we still all end up connected right here to some common ancestor. A cladogram is a model, it's a diagram, and it is a way for us to represent these relationships on a tree of life in a much easier format than drawing all these leaves. So I'm going to start right off by showing you what a cladogram looks like. So here's an example of one, all right? And it kind of looks like it has branches on there a little bit, and you can see some different things. But I'm going to go ahead and just talk to you about this particular cladogram, and then we will go back through and we'll actually sort of break it down and go through a few questions and make sure you're comfortable with it. After you watch this video, there'll be another short video that you'll watch to kind of summarize, and then we have a Google worksheet that you'll complete for us, and we'll see how well you're doing with your cladogram work. All right, so you notice up here, right up here across, I can draw. Let's see, there's my pen. I'll pick pink. Ooh, that'll be fun. All right, so up here you notice that we have some organisms. We have a shark, a tuna, a frog, a human, a hare, a bunny rabbit, a caiman, which looks like an alligator-y thing to me, and a parrot. So we have our organisms right here. And then there's a line from each organism that comes down to sort of this one main line, this main branch right here. So one thing I want you to understand is that this indicates time. Okay. So the oldest, when we're talking about, how long ago, the oldest is going to be down here. Okay. And this will make more sense to you in a minute, but the most recent developments on our cladogram are going to be up here. So this represents time. Okay, so I'm sad. I'm not as good as that guy on Khan Academy. There we go. Okay, all right. So we have our organisms. There's a line that connects each organism to kind of this main branch. And we're looking at the development of things from the oldest to the most recent. And you also notice on here that there are some characteristics right here, right here. There's some different characteristics. And so the way that you read a cladogram is you look at each characteristic. And for example, this first one says vertebrae. And we're to make it easy, we'll say, okay, a backbone. All right, which things have a backbone? And this one is right here. And that means everything to the right or above that characteristic has a vertebra. So that means all of these, the shark, the tuna, the frog, the human, the hare, the caiman, and the parrot, they all have a vertebra. We go up to the next step and it says bony skeleton right here. Only those organisms to the right of that trait have that trait. So you notice the shark is left out now. The shark does not have a bony skeleton. It has a vertebra, but not a bony skeleton. And that's because sharks are considered to have cartilage instead of true bone. All the rest of these actually have a bony skeleton. And so we'll move up to the next one that says 4 limbs. Only, so I'm just kind of putting my pen right here, only the organisms to the right of that trait have that trait. So I'm drawing my arrow up here. That means the frog, he's got 4 limbs. I see him. Humans, 2 arms, 2 legs. That's 4. The hare has 4, the caiman, and the parrot. Don't forget the wings. Those are limbs. Tuna fish does not have limbs. It's got fins, but not limbs. We work our way up. There's our amniotic egg. That is an egg that is enclosed in amniotic fluid. So that is the human, the hare, the caiman, the parrot. The frog is left out of that. I see the word hare right there, and I'll talk to you about that in just a second. When you look at the skull of different organisms contain a different number of openings. And if you look right here, this tells me that the caiman and the parrot have 2 skull openings. The human and the hare, that's not true for them. We can't say that. And I know that because this characteristic is right here. So only the caiman and the parrot have there. These characteristics tell us, the way they're placed on here, that vertebra, in an evolutionary sense, was a trait that evolved at the oldest time point. Bony skeletons would have evolved more recently, 4 limbs more recently as we work our way forward. And you notice that as you go this way, we branch off and they've added the word hare, and then you have a different kind of hare and our human over there. So these are just characteristics that we are using to help us develop our cladogram. Now, another thing that I wanted to point out to you is that you notice that these branches intersect. Okay, so if I follow the caiman line and the parrot line right here, they intersect at that point. That point right there is where a common ancestor of some sort was. And at that point, scientists feel like that organism, some of them evolved into, remember, this is over millions of years, into our modern day caiman, and some of them would have evolved into our modern day parrot. So you notice that I have a point here, that there was a common ancestor. It's anywhere there's an intersection. So I can bring this on down. There's a point where I had a common ancestor. There's a common ancestor here and here. Okay. Now, this is important for a couple of reasons. One type of question that you guys will be asked when you look at cladograms is they like to ask you about how closely related things are based on the cladogram you're looking at. So in general, the closer together 2 organisms are on the cladogram, the more closely related they are from an evolution standpoint, meaning the more DNA they have in common, the more characteristics they have in common. But another way to look at that is we also say that if you're looking at some organisms and trying to decide which are the most closely related, the more recent their common ancestor is, the more closely related they are. So let's look at an example, and we'll look at some other examples as well. But let's take this tuna, and let me ask the question, is this tuna more closely related to I'm trying to think of a good one, to the shark, I guess, or is this tuna more closely related to, I guess I'll do to the frog, okay? So let me pick a different color. What have I not used? Ooh, I haven't used, ooh, I could use yellow. Wonder if blue shows up. I'd like to use yellow, but I don't know if it shows up. No, I don't think the yellow shows up. I'll go to the red. All right, so here's our tuna, okay? If I trace the tuna and the shark down right here, is the most recent common ancestor of the tuna and the shark. And that's as far back as we go on our cladogram. If I trace the tuna and the frog down, the most common ancestor is right there. This is a more recent common ancestor. And so that tells me the tuna is more closely related to the frog. Okay, so again, I did that example on purpose because, see, they're right beside each other. So sometimes you need to look at that. Also think about this, the number of characteristics. The tuna only shares one common characteristic with the shark. They're both vertebra. But the tuna and the frog both are vertebra and both have a bony skeleton. So the tuna shares two characteristics with the frog. It shares more characteristics with the frog, and it also has a more recent common ancestor. All right. Now, some of them are easier than that. I'll pick blue. Okay, I'll pick blue. Some of them are a little bit easier. So, for example, if I were to say, is the frog, I don't know, is the frog more closely related to the human, or is the frog more closely related to the shark? I mean, that one's easier, right? The frog is right here, and you kind of don't have to do those. So you have to kind of think it through. You want to look at, yes, sometimes it's pretty easy. It's the one that's closest. The human right here is more closely related to the hare. They had the more recent common ancestor. So you want to look at the common ancestors, and you also want to look at the number of characteristics that they have in common. So a few of them can get a little bit trickier. All right, I think that is everything I kind of wanted to set you up for. Now, I learned my lesson. I started to do this video before, and I could not figure out. I thought there might be some cute little way to just erase this drawing, like click it. And if there is, I can't figure it out because I clicked an X and the whole thing, I lost my whole thing. So I'm going to try that. Go back to my mouse. All right, so let's go to the next one. All right, so now that I kind of showed you cladogram, here's what you would write down on your note sheet. It's a branching tree-like diagram used to show the evolutionary relationships among organisms. They are kind of like a family tree. Usually, the closer together two organisms are on the diagram, the more closely related they are to each other. I see a little green mark on there I didn't get. This means that they share more DNA and more important characteristics. Cladograms are based on shared inherited features. So those things, those different characteristics that you saw that we added, like four limbs or bony skeleton, we're looking at different features that are inherited and are passed down. And you know that little green thing is going to bother me. I got to get rid of it. Okay. All right, so hopefully you saw this. Each has its own history. So if we talk about the history, the evolutionary history of a parrot, this red part right here from the common ancestor on is showing me this is whatever organism that was. This is its unique, distinct, individual path that it took to evolve into a parrot. But you also have some shared history, right? So because we knew there was some organism back here that somewhere back in time there was a common ancestor, and this thing kept going and going and going until this right here, until natural selection and environmental pressures made them each take a distinct pathway. So if we give you something like this and we say, hey, there's organisms A, B, and C. I don't know what they are. They can be anything. And we asked you where the most recent common ancestor for organisms A and C. You would just take the lines, trace them to where they intersect, and it should be right there. If we said which part of the diagram represents the shared history of all three organisms, the shared history of all three organisms, it's this part back here. Because look, at this point, this one has its own unique pathway. But whatever was going on right here It's in common to all of them. And then finally, that last question says, which part of the diagram represents the unique history of just organism B, its own little pathway? It would be that. So these are some of the different kinds of questions that we want you to become comfortable with. Organisms that share a more recent common ancestor with one another are more closely related. So which is more closely related to the caiman? Here's the caiman. Is it the hare or the parrot? Now here's the thing. Remember, they look equally, it's right in the middle of those two. So I'm going to go to which one has a more recent common ancestor, okay? So here's the caiman, and I notice that right here is where I would have a common ancestor. Grab my pen. Right here, I would have a common ancestor of the caiman and the parrot, and remember, that's more recent. And my other choice is the hare. Well, to get to the hare, I have to go back here. That's farther back in time. So this tells me the caiman is more closely related to the parrot than it is, see, look, I'm remembering to erase, than it is to the hare. The more shared history between two organisms, the more closely related they are. So we did a good job. So the caiman is more closely related to the parrot because it has a more recent common ancestor. Cladograms represent hypotheses about evolutionary relationships, which is who's more closely related to whom. Now, guys, remember that this is a model. And so as we get more information, our model will change. These relationships are based on shared features. That's what these things are right here, those shared features that have been inherited from a common ancestor. And these letters in this diagram represent the appearance of certain inherited features. So in other words, we can have some idea of when in evolutionary past history by examining fossils, these different characteristics appeared. So here's our cladogram we're working with, our same one. And the first question says, where is the most recent common ancestor of the parrot and the human? All right, parrot and the human. I'll grab my pen. You know, I want a different color and I can't find one. All right, what am I looking at? The parrot and the human. So I just trace it right there. That's the most recent common ancestor. Which organism is most closely related to the human? I think we've already looked at that, but that would be the human and the hare. They are beside each other, but they also have the most recent common ancestor. And then they also have the greatest number of characteristics in common. They both have hair. They both have an amniotic egg, 4 limbs, bony skeleton, and vertebra. And then I think we already did this one. Is the tuna more closely related to the shark or to the frog? Okay, more closely related. Let's go back and find those common ancestors, tuna and frog right here, or tuna and shark right here. This is the more recent common ancestor between the tuna and the frog, and the tuna and the frog also share 2 characteristics, vertebra and bony skeleton, and so the tuna is more closely related to the frog. I'm going to erase. Let's see, did I get it all? Okay, sorry. Now here's something fun. Tucker will like this. What about if I stuck a T-Rex in there? Now what are you going to do? There's a T-Rex. Well, let me see here. Did he have a vertebra? I think so. I don't know a lot about him, but I think he had a backbone. Did he have bones? Yeah, it looks like he had bones. That'd be awfully hard to stand up without him. Does he have 4 limbs? Well, yeah, look, those 2 are little, but I definitely see 1, 2, and then there's 2 little ones there. Like, what? Did he have an amniotic egg? I don't know. Beats me. Did he have hair? I don't know. I'm not sure about that either. Did he have 2 skull openings? I think maybe they did. So if he had two skull openings, he'd have to be up on this part of my branch, because I know that two skull openings is a much more recent characteristic that has evolved. But here's what we tend to do with this. We tend to make these tables that look like this, and this will help us. And I'm going to show you a little bit about one of these tables in just a second. I might actually, I've got to take my car to get an oil change here, so I may actually have to do that in a separate video. But what we did here is we took a table, all our organisms, and all we did is we put a plus sign if it has that characteristic. So you notice they all have a vertebra, but when we went up the next level to a bony skeleton, we said the shark did not have a bony skeleton because he's made of this cartilage, but the rest of them all do. And here's our forelimbs, and here's our amniotic egg. Now you notice they even put a little question mark there. Well, I don't know if the T-Rex had an amniotic egg, not completely sure, but this is interesting. Does have, it says opening in front of eye. That means it does have two openings in the skull, two openings in the skull. And I want you to look. So if he has two openings in the skull, we know he does because we have found the fossilized remains. We know he does. We know that's a more recent evolutionary development. We know he has to end up here. He's got to end up here somewhere with the caiman and the parrot. I don't know. I don't know if he's more closely related to the parrot or the caiman, but he's got to end up somewhere in that spot. So let's add some more characteristics. Since I know he's got to end up somewhere up in there, here's our characteristics, but let's add some more in because I want to see, hey, is he more closely related to the parrot or the caiman? So let's look at some other inherited traits, okay? Does that dino have a heel bone? And we have fossils, so pretty easy to see. Turns out a caiman does, a parrot does not, and a T-Rex does not. Bipedal, the ability to stand on two, bi means two. Well, the parrot can stand on two, and there he is, he's standing on two. And if we look carefully, do they have a fourth and fifth finger? Now notice it says fourth and fifth finger lost, and that's a little confusing the way they do that. But basically, they're saying these have lost their fourth and fifth fingers, so they put this. So I want you to look. Let's just look at our additional shared characteristics here. Just look at this. Just look at this part right here. Okay. If we compare the T-Rex, the parrot, and the caiman, let's look at the characteristics. Let's look how similar they are. And you notice here that the T-Rex, look, his pattern of characteristics right here lines up with the same pattern as the parrot. And that tells me that the T-Rex was more closely related to the parrot. This is from an activity you can find online. It's actually called, What Did a T-Rex Taste Like? And I think the idea is you're supposed to say he tasted like chicken. So I would add the T-Rex in here. He is more closely related to the parrot. Notice, look what we did. We added in, we said, well, the development of this heel must have happened along this pathway as the caiman was developing. And right here, we've added bipedal and missing the fourth and fifth fingers. But it tells us that the T-Rex is more closely related to the parrot with the common ancestor right there. So here's a little bit more practice for you. Here's a different cladogram. This one has a hagfish, a perch, a salamander, a lizard, a pigeon, a mouse, and a chimp. There we go. And our characteristics: jaws, lungs, claws or nails, feather, development of feathers occurred along this individual unique evolutionary pathway, fur and mammary glands. I guess they kind of smooshed one together there. All right. List a characteristic that lizards and mice share. All right, well, here's my lizard. Here's my lizard, okay? And I know that lizards have, because I know where he is, okay? So I know that lizards have claws or nails, lungs, and jaws. The mouse has all of these things, including the fur and the mammary glands, because I came right there and I'm just looking back through. So the lizard and the mouse both have claws or nails. You could have that. They both have lungs and they both have jaws. Okay. The only wrong answer would be to tell me that a lizard also has fur and mammary glands. If you don't know what mammary glands are, mammary glands refer to the breast tissue, especially when we're talking about the female of the species producing milk for their young. Which organism does not have jaws? All right. Well, if I go to jaws right there, I'll grab my little pen. If I go to jaws right here, I know everything to this way has jaws. So that means this hagfish does not have jaws. That thing looks like, oh, is that its, I don't know if that's its mouth or its end. I don't know. Which organism is most closely related to the lizard? There's my lizard. The pigeon or the salamander? There's a salamander and there's a pigeon. Be careful. All right. Well, here's the first thing. It looks more like a salamander, and it's right beside a salamander. But I don't know. Let me look. I'll get a different color. I'll get green. Okay, here we go. I'm going to find, though, the most recent common ancestor. All right, so lizard and the pigeon, the most recent common ancestors right there. Okay, that's where it meets. And the lizard and the pigeon both have claws or nails, lungs, and jaws. Now, the lizard and the salamander, their most recent common ancestors here, that's older. Remember, oldest is back on here. So that's older. And the lizard and the salamander only have two traits in common, lungs and jaws. So even though the lizard looks more like a salamander, it is more closely related to the pigeon. Okay, it's got a more recent common ancestor and it has more traits in common. See, if I go to the next slide, this is what I learned. If I go to the next slide, that mess goes with it. Blah. Did I get it all? Okay. Oh. So you could have something like this as a test question. Where's the most recent ancestor of the star and the square? Square and the star. Okay, looks a little different, but I'm still just going to come back down. I just have to find the intersection point. Okay, and where's the most recent ancestor of the square and the triangle? Oh, right here. Oops, sorry, went to the next one. Where's the most recent ancestor of the star and the square? Here's the star. Okay, I can go to right there, and here's the square. I just got to come all the way down. Oops, sorry. Let me get that. Oh, it's being mean, guys. Let me exit out and go back there. There we go. All right. I couldn't see it underneath that stuff. Let's see. You just have to go. You've got to follow. There's the star. You got to just follow the pathway down till you find where they intersect. Okay. Most recent ancestor of the square and the triangle. Okay. Right there. And which are more closely related, the star and the triangle? Star. I might have to have a pin for that. Let me see. Wait a minute. The star and the triangle. Okay, star and the triangle intersect right here. Okay, remember this is oldest down here. Star and the triangle right there, or the oval and the triangle. Well, the oval and the triangle, look, I got to follow this triangle and all the way back down here to get to a common ancestor between those two. So that definitely tells me that the more recent common ancestor is between the star and the triangle. This is the more recent common ancestor. This is oldest, and as I go up, they get younger, more recent. So the star and the triangle are more closely related. All right, now here's another thing. Now, what if I just didn't give you the cladogram? What if I gave you instead, what if I gave you a table like this of all of these characteristics and I told you to see if you could draw the cladogram? Could you do it? So this is a shark, a bullfrog, a kangaroo, and a human. And they all have vertebra. The shark does not have two pairs of limbs. Only these three do. Bullfrogs don't have mammary glands. Only the kangaroo and the human. And then humans are the only one that has a placenta. And that's why you have a belly button. Your umbilical cord ran from your belly button to your mom's placenta. So if you want, you could pause the video right now and you could actually see whether or not, could you draw the line? Could you draw the branches? Could you put the characteristics in? And I'll go ahead so you could stop the video and you could see if you could do it. But there's the answer. Looks a little blurry. And so remember how we draw. They all have vertebra. Shark do not have limbs. So you notice this would be the next characteristic that evolved. Only the things above to the right have that characteristic. Now our bullfrogs don't have mammary glands or placentas. And then finally we get all the way up here and our humans are the placenta. This also tells me humans are more closely related to kangaroos than they are to bullfrogs. And that makes sense as well. All right, so I'm going to stop right here. I'm going to do this on a separate little video, okay? Because I want to show you, this is actually a cool thing. You can go to this website, and the reason I'm stopping now is you can go to this website. I'll have it linked for you, and you can actually try this on your own a little bit. But I'm going to show you, I'm going to video record it to show you kind of how to work through it too. So I'm going to stop this video here. Below this, you're going to see a link to this website. Go to this website. You just click here and there's a drop-down menu. It's a little finicky for each of these things. And after you look at it, it's going to see if you can develop a cladogram correctly for it, okay? And then I'll show you I'll walk you through and make a separate video to see if you got it right, okay?